lecture 3 of the chapter Atoms. In the previous lecture, we have discussed the Bohr's atom model, the introduction, basic postulates, as well as the limitations. In this lecture, we are going to discuss the Bohr's theory of hydrogen atom, expression for radius of electron orbit, radii of electron orbits, expression for velocity of electron and velocity of an electron in orbits. In previous lecture, even though we discussed the limitations of Bohr's model, the Bohr's model helps us in understanding the nature of an atom, which is very much required to deal with the actual understanding of atom with the further proposed models. The Bohr's theory is very, very essential. Let us discuss the expression for the radius of an electron in stationary orbit. We consider an atom with the atomic number Z, such that Ze will be the charge of the nucleus, and an electron of charge minus e revolves around the nucleus. Let R be the radius of the orbit. Let m be the mass of the electron, v be the speed of the electron, and r be the radius of the electron in the circular orbit. Now, what makes an electron to stay in the stationary orbit? It is the electrostatic force. Now, this electrostatic force produces the necessary centripetal force. So, hence we can write mv square by r is equal to 1 upon 4 pi epsilon naught into Ze into E by r square, that is charge of the nucleus and the charge of the electron, divided by square of the distance, which can be further written as mv square r is equal to Ze square by 4 pi epsilon naught. Let us call this as equation number 1. Now, according to Bohr's second postulate, mvr is equal to nh upon 2 pi. So, therefore, on squaring, we can write m square b square r square is equal to n square h square upon 4 pi square. Let us call this equation as equation number 2. Now, if we divide equation 2 by equation 1, we get mv square r square divided by mv square r, which is equal to n square h square upon 4 pi square divided by Ze square upon 4 pi epsilon naught. So, we are left out with m into r is equal to n square h square epsilon naught divided by pi Z e square. Thus, the radius of nth orbit can be given as Rn is equal to n square h square epsilon naught divided by pi m z into e square. Now, for hydrogen atom, the atomic number Z is equal to 1. So, therefore, the expression for the radius of nth orbit reduces to Rn is equal to n square h square epsilon naught divided by pi m e square. So, for first orbit, n is equal to 1, and if we substitute the values of Planck's constant, mass, charge of electrons and permittivity of free space, we get the value of the radius of the first orbit which is given as R naught is equal to 0.53 into 10 raised to minus 10 meters. This radius, or the radius of first orbit of the hydrogen atom, is called Bohr's radius. Remember, it is called Bohr's radius. Now let us try to find the values of radii of electron orbits. Now radius of nth orbit of hydrogen atom is given as Rn is equal to n square h square epsilon naught divided by pi m e square. The radius of first orbit of hydrogen atom is R naught is equal to 0.53 into 10 raised to minus 10 meters, as we calculated in the last slide. So it is called Bohr's radius. Now the radius of second orbit is R2 is equal to, now try to understand, rest all remain same. It is n square into R naught, so therefore we can write it as 2 square into 0.53 into 10 to the power of minus 10 meters, which is equal to 4 into 0.53 into 10 to the power of minus 10 meters. Hence the value becomes 2.12 into 10 raised to minus 10 meters. The radius of third orbit of the hydrogen atom can be calculated as 3 square into Bohr's radius, that is 9 into 0.53 into 10 to the power of minus 10 meters. The value becomes 4.77 into 10 to the power of minus 10 meters. So on, if I can write the value of radius of nth orbit in terms of Bohr's radius, I can generalize it as Rn is equal to n square into 0.53 into 10 to the power of minus 10 meters. That is, Rn is equal to n square into R naught. Thus, the radius of nth orbit of hydrogen atom is proportional to square of principal quantum number, or the number of orbit. So as the number of orbit or principal quantum number increases, the radius of the orbit also increases as the function of its square. So as we move away from the nucleus, the spacing between two consecutive orbit goes on increasing rapidly. Now let's move on to the discussion of expression for the velocity of the electron. Now again, let us consider an atom of atomic number Z. Then Ze becomes the charge of the nucleus, and let minus E be the charge of the electron revolving around the nucleus. Let m be the mass of the electron, r be the radius of the orbit in which it revolves, and v be the velocity or speed of the electron. Now again, the electrostatic force produces the necessary centripetal force. It is given as mv square by r is equal to 1 upon 4 pi epsilon naught Ze into E by r square, which can be simplified to mv square r is equal to Ze square upon 4 pi epsilon naught. We call it as equation number 1. Now according to Bohr's second postulate, that is quantum condition, we have mvr is equal to nh upon 2 pi. Let us call this as equation number 2. If we divide equation 1 by equation 2, we get mv square r divided by mvr is equal to Ze square upon 4 pi epsilon naught divided by nh upon 2 pi. On simplification, we get the expression for velocity as Vn, that is velocity of an electron in nth orbit, is equal to Z. Thus, for hydrogen atom, where the atomic number Z is equal to 1, the velocity of the electron in nth orbit is Vn is equal to E square divided by 2 epsilon naught n into h. Now if we list out the velocity of the electron in various orbits. The velocity of an electron in nth orbit is given by Vn is equal to E square divided by, so this is for hydrogen atom, Vn is equal to E square divided by 2 epsilon naught n into h. Vn hence is inversely proportional to the principal quantum number. Vn is proportional to 1 upon n. The velocity of an electron in first orbit can be written as 2.19 into 10 to the power of 6 meter per second. In second orbit can be written as 1.095 into 10 to the power of 6. And in third orbit it is 0.73 into 10 to the power of 6 meter per second. Now try to understand, as we move away from the nucleus, as we choose the orbit which is away from the nucleus, as we move outwards, the velocity of the electron decreases. The speed of the electron in that stationary orbit decreases. Thank you.